Hi everyone, so in this video we're going to talk in a little bit more detail about what the operating system actually does. So in the previous video I talked about kind of the different bits of the operating system such as utility software and the operating system itself, like system software in general. So I'm not going to talk about that here, so if you want to kind of learn more about that, have a look at the other video. But in this one we're going to talk about this specification point here, which basically talks about the need for the functions of the OS and what it does, so what it handles. So this section just here, basically, just trying to get my pen working. There we go. Okay, so this kind of section here. So we need to understand that the OS handles processors, memory, input and output devices, applications, and system. It deals with security as well. So a quick recap. Remember, there's operating systems are generally just things that we use in our computer to manage all the components. So your hard drive, your CPU, your RAM, all of those work on their own thing, and the operating system brings them all together and allows them to communicate and work effectively. So first thing I want to talk about is how the operating system works with the processor. So just a reminder how the fetch execute cycle works, because this is quite crucial really. So what you've got really is your CPU here, like so, okay, and then over here somewhere you have RAM, so, and there's your RAM and all the different instructions handling RAM. And you've got an address bus connected here, AB for address bus, and then you've got a data bus here. Okay. And what happens is every kind of pulse of the system clock, what happens is the CPU will fetch the next instruction, so it will send a request, e.g. position number 1, from the CPU to RAM, and let's say that's position 1 and there's some binary in there, let's say, okay? What will happen is it will go, right, there's position 1, it will take out 0101, send it back to the CPU, and in there it'll be decoded and executed, and that process just starts all over again. So what happens is something called the program counter inside the CPU, and that increments every system clock. So that'll tick again, and then we get number 2, and then what will happen is the next instruction will be fetched along the address bus, taken from whatever that is in address position 2, taken back along the data bus, and then decoded and executed in the CPU. And that process is basically how computers work. It's a constant cycle of going through RAM, pulling out the next instruction on every system clock pulse and bringing it back into the CPU. And that's basically computing 101 really. So how does the operating system come into this? Well, the thing is, the CPU will generally just do what it's doing, basically. It will just keep ticking over every time, going round and round and round. But the thing with a computer is there's different instructions that need to be run at different times. Some are more important than others. You might get an interrupt, which is a really crucial thing that has to be handled there and then, which can't be ignored, really. So in that respect, what happens is the operating system, will tell the CPU how to manage its time. So we use something called scheduling. So if I make some notes in here, actually, to show you what I mean. So what happens is the processor, let's highlight that, the processor has lots of different instructions going on. So the OS deals with scheduling to make, can't spell today, the most effective use of the processor. So what it will do is, if you imagine a CPU might just focus on one job, like, oh, I've got Word open, let's just focus on Word. And actually the operating system knows that that's not the right thing to do. It needs to spread its time onto different projects and different parts of the system. So what it does is, using scheduling, or one could be called time slicing, what it does is it will split its time and go, right, I'll deal with a little bit of this, a little bit of this, a little bit of this, and then come back to it, and we kind of carry on in this cycle and this loop. So the operating system's in kind of charge of that. It's also in charge of priority requests, so these could be called interrupts, making sure that highest priority instructions are done first. So it will bump things up in the queue. So if you remember we talked about here with this kind of RAM, it will make sure that actually if instruction number 4 is far more important, then that will be done first over like instruction 3. So it manages that and makes sure it knows which are the interrupts and which are more important than others. So it will jump from one to the other. And yeah, it also allows multitasking as well. Multitasking within the processor, because by jumping between different processes, using this kind of scheduling concept, it means that you can make use of really efficient use of your processor by jumping between this project and this project and this project. So it kind of goes between the two really quickly, therefore making the most efficient use of time. So that's kind of how the operating system helps the processor be more efficient. Now let's have a little chat about memory, okay? So we already talked about RAM, and that's kind of RAM here. So this thing here, which is this almost imagine like a table of instructions with lots of binary in there. And what the operating system does, it manages how much RAM a process has access to. So if you imagine, certain instructions don't need a lot of RAM, do they? Some different programs need a lot, some programs don't need enough, don't need a lot, sorry. So what it will do is it will kind of decide, right, this program is getting X amount of RAM, this program is getting X amount of RAM, and therefore trying to make sure that not too much RAM is used and making sure that it's kind of fairly split. The way to think about it is an image editor using kind of high quality pictures is going to use way more RAM than, say, just a simple text editor like Notepad. So therefore, if the computer was to allocate equally RAM to every program launched, then it would run out of RAM very quickly. So by using this, it's a clever way of making sure that the operating system kind of helps the processor know, or the RAM, know how to allocate to different programs, which is quite useful really as well. It also makes sure that the operating system doesn't overwrite certain instructions that have been used for certain applications. So the OS also helps manage current instructions in RAM and ensures they are not overwritten if needed. So yeah, so again, if you've got these instructions currently in RAM used for other processes, you don't want to get them overwritten. That would just be silly. So that's another thing it makes sure that's okay. So that's how the operating system helps memory, or RAM in this case. Let's now have a chat about input and output. So as you know, there's lots of devices we can plug into our computer system. Input devices, output devices, mice, keyboards, you name it, okay? And what it does, it creates an interface. So the operating system creates an interface between the computer and the device. So having that connection really, because you've got to imagine that these different kind of applications, these different peripherals, they almost speak a different language to the computer. So there's got to be a way to allow them to communicate together so we can get them to do what they're going to do. And that's done by using the device drivers. So the OS manages device drivers to ensure that I/O devices can communicate, because it's kind of like the translator really. So having the driver is like the communication, the line to say, oh, I understand what you're saying now, and the operating system manages all that and does all that stuff there. The operating system as well also manages the OS also manages updates and fixes. There we go. Real lag on my keyboard today. Fixes for the device. So there we go as well. So it makes sure that if there's any lags or there's any issues with the device not working properly and you want to do an update, then the operating system is in charge of that and making sure that the updates are there and pushed out and installed on the computer. So there we go. That's what it does. The next one, it does applications. So applications obviously are like software which we use, like Word and PowerPoint, or word processors and presentation software. Remember, we can't use brand names in the exam. So it creates a platform for the application software to run. Platform. So without the operating system there, the application software just couldn't run. You just couldn't have Word and PowerPoint and games, video editing software. It wouldn't be there. So that's what it does there. It also allows applications to access hardware, including access to RAM as well. So allows application software to access hardware, RAM, which is obviously going to be useful for certain applications, which is great. Also provides a user interface. My lag is awful on this. Look at that, that's anything. Provides a user interface. So yeah, when you first load up Windows, for example, you put a lovely desktop, that's obviously a user interface, and that's something that the operating system provides, and that's not built into the computer as standard. And you'll know of various other things like Android on your phone or iOS. They're all kind of GUIs or kind of user interfaces that we know and we get used to using, and things like that really. So it takes advantage of all those different things. Okay? And the last one we'll talk about that it does is security. So security obviously is really important because we want to make sure our devices are safe and secure. So the operating system allows security features to be used. So that includes things like, passwords, you name it, passwords, usernames, like biometrics, if obviously you have that on your on your device, that's like fingerprint scanners, or on your phone, or like eye scanners. So it does all that stuff. Also, what it does as well is it also does access rights. So remember we talked about access rights, which is certain users can see certain files and some can't. So it also manages access rights to make sure that, if you take a school, for example, someone like the head teacher, they can see everything in the school, every single file, every single document. Whereas, someone who's maybe who doesn't need access to those, like, I don't know, like a new teacher, they don't need to see they don't see their classes and their lessons. They don't see what the head teacher sees. So having access rights means that data can be kept safe and secure, making sure that the wrong people don't have access to certain files and folders that they shouldn't be able to see. And yeah, it's just got all other things in there as well, really. PIN protection, fingerprint scanner, you name it, really. Any kind of security you can think of, it's managed by the operating system. There we go, guys. So that pretty much summarizes this 5 bullet points here. I know it seems like quite a lot, but that if in the exam you might get a question that says, right, here's give 3 things that the operating system does, and it's normally worth about 6 marks. So you get 3 marks for just saying, say, processor, memory, and input and output, but then you get the extra 3 marks for actually explaining a little bit more depth about what each of these headings is. Hopefully there's enough information there to help you prepare for that part of the exam. So there we go, guys.